Today we are going to study Science and Technology Part 1st. Chapter 1 Gravitation. Gravitation. The phenomenon of gravitation was discovered by Sir Isaac Newton. We all know the famous story that once Newton was sitting under the apple tree. Then the apple fell off on the ground. Seeing this, he wondered, why didn't this apple fly off in the horizontal direction? Why did it only fall downwards towards the ground? After much thinking, he came to a conclusion that there must be some force on earth which is attracting this apple towards itself. The direction from the apple on the tree is towards the center of the earth, is in vertical direction. Thus, the apple falls only vertically downwards. Circular motion. The motion of an object along the circumference of the circle or rotation along a circular path is called a circular motion. For that, first we have to understand what is actually motion. When there is some movement by a body or object, it is termed as motion. So, in short, circular motion is the motion where the object moves in a circular path. Take a look at the image. The boy, he is moving the string with attached weight at the end in circular way. This is the example of circular motion as it forms the curved path when it is moving or is in motion. Centripetal force. A force acts on any object moving along a circle and it is directed towards the center of the circle. Then that force is called as centripetal force. Centripetal means center seeking. That is, when the object tries to move towards the center of the circle because of the force. Take a look at figure 1.2. A stone tied to a string moving along a circular path and its velocity is in tangential direction, represented by pink arrow, which is tangential to the circular path. The another arrow is pointing towards the center where the person is holding the string. This arrow indicates the force that is pointing towards the center, called as centripetal force. Thus, in short, we may say that the centripetal force is the force that is directed towards the center when the object is in circular path or circular motion. The opposite of centripetal force is centrifugal force, directed away from the center. About it you may study later. Now, we know that the moon is the natural satellite of Earth and goes round the Earth in fixed orbit. The direction of the motion of moon as well as its speed constantly changes during its motion. So, do you think there is some force constantly acting on the moon? Well, it is clear that for the moon to go around the earth, there must be a force which is exerted on the moon, and this force must be exerted by the earth, which attracts the moon towards itself. Let's understand this by taking a look at the image towards the left. The earth has its own gravitational field, which attracts the object towards itself. So the moon is attracted by this gravitational field. But if this gravitational field is much stronger, so the moon should have fallen on the earth. How come it isn't? So there might be some other force which is helping the moon to balance the gravitational force. That is centrifugal force. As gravitational force is acting towards the center of the earth, attracting the moon towards itself. So centrifugal force acts away from the center to help the balance of the force and to help the moon to remain in its orbit. And these two forces helps the motion of the moon round the earth. Similarly, the sun must be attracting the planets, including earth, towards itself. Kepler's law. Kepler noticed that the motion of the planets follows certain laws. So he stated 3 laws describing planetary motion. These laws are called as Kepler's law. Kepler's first law. The orbit of a planet is an ellipse with the sun at one of the foci. Take a look at figure 1.4. Point A, B, C, D, E, F are the points on the ellipse. This ellipse is the orbit of the planet, indicated by blue dot. The figure shows the elliptical orbit of a planet revolving around the sun. The position of the sun is indicated by S, which is indicated by red dot. Thus, Kepler's first law conveys that the orbit of the planet is in elliptical shape. Kepler's second law. The line joining the planet and the sun sweeps equal areas in equal interval of time. Take a look at figure 1.4. AB and CD are distances covered by the planets in equal time, that is, after equal interval of time. The position of the planets starting from A and C are shown by B and D respectively. The straight line AS and CS sweeps equal area in equal interval of time, that is, area ASB and CSD are equal. Because of the elliptical orbit of the planet, the distance between the sun and the different points on the orbit differs, but the area covered at a particular time remains constant. That is, if for travelling from point A to B, the planet covers about x unit square of area, then the time required may be 1 hour. Let's suppose. Then while travelling from C to D, it will cover same area, that is about x unit square, if the time required is also same, that is 1 hour. Thus, Kepler's second law shows that equal area is covered in equal interval of time. Kepler's third law. The square of its period of revolution from the Sun is directly proportional to the cube of the mean distance of the planet from the Sun. That is, if r is the average distance of the planet from the Sun and t is its period of revolution, then t square is directly proportional to r cube. That is, t square upon r cube is constant, is equal to k. Thus, Kepler's third law shows the proportionality relation between the period of revolution and mean distance of the planet from the Sun. Here are few practice questions. Do answer these questions. If you have any doubt, do ask in the comment section below. Do subscribe my channel and click the bell icon for notification. Do like and share the video. Thank you.